Okay, so here we are with Chapter 7, Section 4. We're going to be looking at confidence intervals for sigma and sigma squared. So that is confidence intervals for standard deviation, that's sigma, and variances, that's sigma squared. All right, so the change here is, well, um, we have a new distribution to consider. This is the chi-squared distribution, or, if you want to write it out in words, it's the chi-square distribution. Okay, so the chi-squared distribution looks kind of like this. All right. All of the values are greater than or equal to 0. So we can actually go ahead and put the y-axis right here. This is a family of curves that are based on degrees of freedom. So like the t distribution, we're going to be looking at the sample size to determine our degrees of freedom. And in fact, it's the same as in that situation, exactly. The degrees of freedom are n minus 1, where n is the sample size. Okay, all of these are positively skewed. So I draw mine kind of like this. All right. Remember, it said it is a family of curves. So for different values of n, so that means differing degrees of freedom, we have the curves looking slightly differently. As you should be able to see in the book, as n grows large, the value or the curve approaches a more symmetric shape. It's almost like the bell curve there, except it's very, very skewed to the right, because remember, all of these chi-square values are greater than or equal to 0. Okay, so we'll go ahead and look up or perform basic things with our chi-square distribution. So we'll flip to this example over here. And in example, one second, shift it a little bit. Let's see. In example 7-13 says to find the values for chi-squared right and chi-squared left for a 90% confidence interval when n is equal to 25. All right, so let's go ahead and break that down, figure out chi-squared right and chi-squared left. I call it a little something differently, but I'll go over both my notation and the book's notation. All right, let me go ahead and put the book down and write this up. So this is example 7-13, and we're on page exact 400. Right, so we're going to go ahead and find chi-squared subscript right and chi-squared subscript left. Okay, and we are given that n is equal to 25, and oh, sorry, I was getting ahead of myself. I almost wrote percent. And our confidence level for our confidence interval is 90%. Okay. All right, so the first thing that I'm going to do here is I'm going to go ahead and sketch the distribution, and I'm going to explain a little bit about the notation. So in all of these are going to be skewed to the right like this. That's positively skewed that way. And the thing about the chi-squared distribution table, or looking up the values in the chi-squared distribution, is it gives us right side areas. If we want to make a confidence interval, of course, we have to use the middle area. Essentially, we're going to be looking at the left and the right tails and throwing those ones out. But you know, we want the same kind of thing to happen here. If alpha in this case, so 1 minus alpha is 0.9, so that means alpha is equal to 0.1, so therefore alpha over 2 is equal to 0.05. Okay, it works the same exact way. The area underneath this left tail is 0.05. The area underneath this right tail is also going to be 0.05. This one, they call it chi-squared subscript. Let's see, right. And this one over here is chi-squared left. And I can never remember which one's which, but it should be okay for you guys to figure out. This one's on the left, this one's on the right. Okay. The notation that I will sometimes use is as follows. These are right side areas. So I call this one chi-squared, and this would be alpha over 2, because the area to the right of this chi-squared value is whatever alpha over 2 is. Okay. And then over here, since I want the area on the left-hand side to be 0.05, or alpha over 2 in general, then that means I want the area on the right-hand side of it to be 0.95. So here, how do we do that in general? It's going to be chi-squared, and I'm going to call it 1 minus alpha over 2. Okay, so we're not going to have a positive 1 and a negative 1. Remember, all chi-squared values are positive. I guess technically we could have 0. So yeah, that is what we'll do here. So basically, the reason that I did it like this instead of saying left and right is 2 reasons. Well, one, it's just the peculiar little way that I have of remembering how the formula goes. It's related to these values rather than left and right. Those ones, for me, I get them switched around. And then second of all, it comes from having to utilize our chi-squared distribution table, which actually, if we're thinking about just whatever number that should be, so in this case, that's going to be 0.05, and in this case, it's going to be 0.95. We're just going to look in one particular column that pertains to one particular value for alpha. All right. Okay, so let's go ahead and do that really quickly. So flipping past the z distribution, here's our chi-squared distribution. And let's prop this up on a little pedestal so we can see it a little bit better. Okay. All right, so the way this one works, again, like I was mentioning, it's based on the degrees of freedom. So we're going to first go ahead and look up and make sure we're in the correct row. And then second of all, it's based on just alpha, nothing more than that. All right, so the alpha values that we're going to be using for the value that's on the left, the first one, remember its subscript was 0.95, and we're just going to slide on down to n equals, oh sorry, not n, n here was 25, it says it right there, right? So n minus 1, the degrees of freedom, is 24. So we're looking right here, 0.95. So that first chi-squared value is 13.848. Okay, 13.848. And then, okay, keep in mind we're going to be in the exact same row, right? Because we have the same degrees of freedom. We just have to go to the column now that has alpha equals 0.05. So for that right chi-squared value, or chi-squared subscript right, we want the area on the right-hand side of it to be 0.05. And that value, I think I'm seeing it correctly, is 36.415. There's a glare on the page. You guys can't see anything at all. So what did I say? 36.415. 36.415. Okay, so here the thing to remember is the table is actually, for us, it's actually nice because it's organized with our left values over here and then the right-hand values over here, because all of these are right areas. So the smaller the right-hand area, the further to the right it is. The larger the right-hand area, that means the further to the left it is. Okay. So there is how we'll utilize the chi-square distribution table.